In this video, we're going to look at solving literal equations. So literal equations don't necessarily have numbers. You will be solving for one variable in terms of another variable, and a lot of times students find this particularly challenging because you're used to working with numbers, and so not having numbers can make the problem seem a little more difficult. So these problems are going to be very similar to those on the Kuta Software Infinite Algebra 1 worksheet. The second page where they get more difficult, I'm not going to do the exact problems there because that's your homework, but I will do some problems and show you how I would go about doing these. So let's take a look. Let's say I had something that looked like this. So x equals y minus zw, and I want to solve this for w. So when you're doing that, you start, your goal is to get the w by itself. And so you're going to start with the things that are farthest away from it, because the last thing you're going to do is going to be to divide or multiply by what's actually touching, what's multiplied to that variable. So we're going to start with the things that are farther away from it. Actually, I'm going to start just because it makes me more comfortable. I want to get the w on the other side and make it positive. So I'm going to add zw to both sides. So then I get zw plus x equals y. Because I can't add the zw to the x because they're not like terms, cancels out on this side. Now, I want to get the w by itself. So I want to look and see what's being done to it. Well, the most immediate thing that's being done to it is it's multiplied by z. The next most immediate thing is x is being added to it. So I want to start with the last most immediate thing. So the last thing that's being done to it is adding an x. So I have to do the opposite of adding an x. So I subtract an x. And then I have zw equals y minus x. And I just leave it y minus x because they're not like terms. Now I'm trying to get the w by itself. What's being done to it? It's being multiplied to z. So I need to do the opposite of multiplication. So I will divide by z. When I do that, these z's cancel, and I get w equals y minus x over z, and that's my answer. Alright, so let's try another one. So I'm going to add some lines to my page to maybe write a little neater. Alright, so let's say I had so this will have some numbers in here, but some variables. So let's say I had negative 3 x plus 7 equals xy. And I want to solve this for x. Okay, so the first thing I need to do is whatever variable I'm looking for, whatever it is, I have to get them all on one side and get everything else on the other side. And when I say them, anything that has an x in it, I need to get it on one side. Anything that doesn't have an x in it, get it on the other side. So I'll move the xy to the left side and the 7 to the right side. So I'll subtract xy from both sides. I'll also subtract 7 from both sides. So 7's cancel. On this side, I get negative xy minus 3x. And on this side, the xy's cancel, I get negative 7. Okay, now I have to do something kind of tricky. xy and 3x are not like terms, so I can't combine them. But my goal is to get x by itself. So what I have to do when I have a situation like this is factor out the x. So I'm going to factor out the x. When I do that, I ask myself, what would I multiply x by to get negative xy? And the answer is negative y. So x times negative y is negative xy. What would I multiply x by to get negative 3x? Minus 3 equals negative 7. Now, trying to get x by itself, look at x, what's being done to it? What's being done to it is it's being multiplied by negative y minus 3. So I want to do the opposite of that. Opposite of multiplication is division. So I'll divide by minus y minus 3. And I get x equals negative 7 over negative y minus 3. Now, because I can't help myself, that is a perfectly acceptable answer. That is correct. But I don't like it because it's full of minus signs. So I'm going to multiply by negative 1 over negative 1. You can always multiply by anything over itself. And the reason I'll multiply by negative 1 over negative 1, so you can always multiply by anything over itself because anything over itself is just 1. And multiplying by 1 doesn't change anything. And when I multiply by negative 1 over negative 1, I get 7 over y plus 3, which to me is just much prettier. So I'll do that. Okay, so now let's see. Okay, let's look at another one. Let's say I had z equals cx plus wx, and I want to solve for x. Okay, just because I like to, I'm going to swap sides so that I have my x on the left-hand side. You do not have to do this. I just like it because now I have my x on the left-hand side. But notice I already have this with the x's on one side and the things that don't have x's on the other side. So I've already got that. Now, if I have more than one thing with an x and they're not like terms, then I have to factor. So I'm going to factor an x out. And then you would ask yourself, what would I multiply x by to get cx? The answer is c. What would you multiply x by to get wx? The answer is w. So you have that. Now, we're trying to get x by itself. What's being done to the x? It's being multiplied by c plus w. The opposite of multiplication, or the inverse of multiplication, is division. So I'll divide both sides by c plus w. Those cancel, and I get x equals z over c plus w. Alright, let's see. Let's say I had 2d minus 2 equals negative 4a plus 3c. And I want to solve this for a. Okay, so I need to get the a by itself, or anything that has an a. Everything that has an a on one side, anything that doesn't have an a on the other side. There's only one thing with an a, and again, just because it's what I like to do, I'm going to put it on the left-hand side. So I'll add 4a to both sides, and then since I'm putting the a on the left-hand side, I need to get rid of the stuff that's on the left-hand side. So I had a positive 2d, so I'll subtract 2d. I had a minus 2, so I'll add 2. So I'm doing the inverse of those operations. So 2d minus 2d, those cancel. Minus 2 plus 2. Yeah, by the way, my 2's look just like z's. If I write a z, I put a line through it. So that's, although only sometimes, apparently sometimes I put a loop in my 2, and sometimes I don't. So anyway, those are both 2's. You know they're not z's because there's no line, so those cancel. And my minus 4a plus 4a cancels. So on this side I have 4a, and on this side I have 3c minus 2d plus 2. Getting a by itself, what's being done to the a? Being multiplied by 4. Inverse of multiplication by 4 is division by 4. So a equals 3c minus 2d plus 2 over 4. Alright, let's say I had negative 2x plus q over xy equals 5. And I want to solve this for x. Okay, well this one is harder. Notice we have two terms that have x's in them, or not terms, but two things that have x in it, the xy right here and the 2x here. There's nothing really we can do with this, and fractions always make things more difficult. So the way you get rid of a fraction is you multiply both sides by the denominator, and when you multiply both sides by the denominator, then that gets rid of your fraction for you, because on the side that has the fraction, the denominator will cancel. So I'll multiply both sides by xy. And when I do that, on the left-hand side, they cancel. Now be careful that you do that. Don't try to distribute this, because the whole reason for multiplying by xy was to make it cancel. So you want to make sure that you do that. When you multiply a denominator, make sure you're doing the canceling. So on the left-hand side, I have minus 2x plus q, and on the right-hand side, I have 5xy. Now I need to get everything with an x in it on one side, everything without an x on the other side. So I'll subtract 5xy from both sides, and I'll subtract q from both sides. And now on the left, so the q's cancel, 5xy's cancel. On the left-hand side, I have minus 5xy minus 2x, and on the right-hand side, I have minus q. So I have two things that have an x in it, and they're not like terms, so I have to factor that x out. When I factor the x out, I'm left with a negative 5y minus 2 equals negative q. And at this stage, you should know what to do. We'll divide both sides by negative 5y minus 2. And then we get x equals negative q over negative 5y minus 2. Okay, I think I'll do one more. Let's say I had x, y equals x plus z, and I want to solve that for x. Everything with an x on one side, everything without an x on the other side. So I'll subtract x from both sides. So then I have minus x plus xy equals z. Now, these are not like terms, so I need to factor an x out. Now, I need to be careful here. When I factor an x out from minus x, I'm left with minus 1. When I factor an x out from xy, I have y equals z. And so now I divide both sides by minus 1 plus y. And those cancel, and I get x equals z over minus 1 plus y. Now in that instance I had a minus x. It would have worked the same if I'd had a plus x. So if I had 3y equals let's say 3yz equals negative y plus 2a, and I want to solve this for y. So I want to get the y's on one side, so I'll add y to both sides, and then I get y plus 3yz equals 2a, because those cancel. Factor a y out, and when you factor a y out from y, you get a 1, because, well, let me finish writing it after I factor, and then from the 3yz I get a plus 3z equals 2a. Now the reason why I get that 1 is because if I multiply this back, if I distribute, I need to get back to what I had up here. So in order to get back to y plus 3yz, I have to have something there. I have to have that 1 there. Because then if I multiplied this back, if I distributed, I get y plus 3yz. So that means my factoring was correct. If I just ignored the y and pretended like it wasn't there, I would not get the right answer. So I have y times 1 plus 3z equals 2a. Divide both sides by 1 plus 3z. And I get y equals 2a over 1 plus 3z.